So we're asked to write the fraction we've been given as a product of its partial fractions. So we'll start off by formulating the equation. So 19x minus 3, and all of this is over 1 plus 2x, 3 minus 4x at this point. That is equal to, unless we can get this as a common denominator, so it's going to be a times the second denominator plus b times the first denominator, and all of that is over the common denominator 1 plus 2x, 3 minus 4x. So we can see that these two fractions both have the same denominator, so we can conclude that the numerators are equal. This is the first stage in any partial fractions problem, is to write out this step here. So then we're going to try and find values of a and b. So we're doing that by choosing suitable values of x. So if we want to make b equal to 0, we'll choose x is equal to minus a half, because that will make this bracket here equal to 0. So if we then put x is minus a half into this equation, we are going to get a value of a, which is 3 minus 4 lots of minus a half, and as I said, b is going to go to 0. So these two things can then just be put straight into a calculator. So we have minus 25 over 2 on this side, and that equals 5a on this right hand side. Then divide through, and we can get that a is equal to minus 5 over 2. So these steps here are just using your calculator. We then need to choose the second suitable value of x. This is going to be the value that makes the bracket containing a 0. So the second suitable value of x I'm going to choose, x is going to be equal to 3/4. So when I put 3/4 into here, I get 19 lots of 3/4 minus the 3. Now it's the a term that's equal to 0, and I'm just going to put 3/4 into the b term. So b lots of 1 plus 2 lots of 3/4. Now once again, evaluating this, we should get 45 quarters on the left hand side. We've then still got our 0 a's, and we've got 5 over 2 b. And then I'm going to multiply by 2 and divide by 5 to get b on its own, and we come that b is 9 over 2. So once we've got our a value and our b value, the final step for these 3 marks is to write out the final solution. And I'm going to do this up here just because I know it's going to be useful for the next marks. So a is minus 5 over 2, so it's minus 5 on the numerator there, and the denominator is then 2 lots of 1 plus 2x. So a is minus 5 over 2. And added to that is b, which is 9 over 2, so it's 9 as the numerator, and again 2 lots of 3 minus 4x. So that's the first 3 marks there, expressing the original fraction in the form a and b. So continuing to part B then, you'll see I've just added a snippet from the formula book there, which is the formula for binomial expansion, because we're asked to do the binomial expansion of our original fraction here. So what we're going to have to do is we're going to have to actually do the binomial expansion on these 2 fractions. So I'm going to start off by rewriting this as minus 5 over 2, 1 plus 2x to the power of minus 1, plus 9 over 2, 3 minus 4x to the power of minus 1. So what I'm doing is I'm just rewriting each fraction to make it look more like what we're going to use in the formula book. So the first one's not too bad, because that's quite similar to what we've got in our formula book here. So we've got minus 5 over 2 and then if we have a big open bracket. Now before I start this, I always just like to write out what I'm doing. X in the formula is going to be replaced by a 2x, and n in the formula is going to be replaced by a minus 1. So I'm going to have 1 plus, now n was replaced by a minus 1, and x was being replaced by 2x. And I'm adding to that, and now this is just the fraction on the top here, so it's minus 1, then n is minus 1, so I'm looking right in here. Minus 1 take away 1 is minus 2, so I've got minus 2 on the top of that fraction. The dot, remember, means times, so I'm dividing by 2, and then it's x squared, but actually no, it's not, it's 2x all squared. And that's going to be times by minus 5 over 2 in the end. So let's just tidy this up a little bit. I'm going to come back to it in a while, but just tidying it up slightly. I've got 2x here. I've got the numerator of this fraction is going to be positive 2, so 2 over 2 is just 1. 2x squared is plus 4x squared. So that's the expansion of my first term. My second term is going to take a little bit longer and is a bit more complicated because we've not got a 1 in this first term here. So we have to make sure that we end up with a 1 there. So before I start, I need to factorise out here. So I'm going to factorise out the 3. So the 3 is going to come out the front, but it's not just a 3, it's 3 to the minus 1. So I've got my 9 over 2. I've got my 3 to the power of minus 1 because I've got a minus 1 up here, which leaves me with 1 minus. Now I've factorised out 3 from this bracket, so I'm going to be left with 4/3 because 4/3 times by the 3 would leave me with the 4. So it's 4/3 x to the minus 1. So similarly to what we've done already, so we're going to add to this. We've got our 9 over 2 times by 3 to the minus 1. So just quickly, just to make this a bit tidier, I could type, that's the same as saying 1/3. So actually I've got 9 over 6, which simplifies to 3 over 2. So I've got 3 over 2 as the front of my bracket here, and then let's just put that in here as well. So 3 over 2, lots of 1 minus 4 over 3x to the minus 1. Now once again, just going to write out that x is going to be replaced by minus 4/3 x. And that minus is very important because our formula states that x is plus, or it's added on to 1. So we've got 1 with the minus, and n is minus 1 again. So putting in what we've got then, so we've got 1, again, formula always starts with 1, plus n, which is still minus 1, same as it was before, and now times by x, which is minus 4/3 of x. And then the second term, we only need to go up to the x squared term, so we've got minus 1 minus 2 again, still being divided by 2, and this time we've got 4/3 x, which is being squared. So tidying this one up, I've got 3 over 2, 1. Now I've got 2 minuses in here, so it's going to be plus 4/3 x. Now I've got minus minus again, so that term's positive. So I've dropped a minus there. So that's a positive 1, 2 over 2. So that's fine. I've then got minus 4/3 squared. So the minus 4 gets times by minus 4, so plus 16 over 9 x squared. So you can see that all 3 of those terms actually end up being positive because the minuses will cancel each other out. Now to finish off and get your 7 marks here, this is now a calculator exercise, okay, because we're expanding each of these brackets, which I will show you, and then we're just going to bring everything together. So expanding these brackets, I've got minus 5 over 2 times 1, minus 5 over 2 times minus 2. So that's going to bring me plus 5x in there. And then I've got minus 5 over 2 times 4x, so minus 20 over 2, which leaves me with minus 10x squared in that one. And then my second bracket expansion is 3 over 2. And then I've got 12 over 6 there, so plus 2x. And my final one, 3 times 16 over 2 times 9, which simplifies to 8/3. So positive 8/3 x squared. So from here, we then just need to bring together our numeric terms, which come to -1, our x terms, which come to plus 7x, and finally our x squared terms, which go to -22/3 of x squared. And that is worth your 7 marks there. So it's using what you did in part A and using the binomial expansions. So that's part B. Now we're looking at B part 2. So that's part 1. B part 2. Only 1 mark for this, but should be quite a straightforward mark to pick up. It's all about this bit. It's all about the range of values. So when x is put into this expression, the absolute value of x must be less than 1. Another way of interpreting that is that x must be between 1 and -1. But we've already stated earlier on in this question, I'll just highlight it here, that actually for the first expansion, x was being put equal to 2x. For the second expansion, it was being put equal to -4/3 x. So that's all we have to do here. If we just instead change this value, so we've got the absolute value of x, which we're changing, so sorry, the absolute value of 2x is less than 1, or the absolute value of 4/3 x. Now I'm going to call it 4/3 x because it takes the absolute, so the minus is effectively ignored. So from here, we can say, well, x then must be, or the absolute value of x must be less than or equal to 1/2, or x, and we're timesing by 3, dividing by 4, so less than 3/4. So if we take this definition again, I'm just going to scroll a little bit, we're going to say that x is either got to be between 1/2 and -1/2, or x has got to be between -3/4 or 3/4. So which one do we have to take for the range for this expression? And it's always the one that's smaller. We can't take this one because this one allows us to include values between 1/2 and 3/4, which are not valid for the second expression. So as a result, this is the final thing, and it's only a mark, so if you wanted to, you don't actually have to worry about any of that at all. It's just a statement of fact for this one here, that x must be between 1/2 and -1/2. If you state it like that, equally fine, also worth a mark.